Alright guys, this is just a quick edited version of Friday's meeting where me and Adam went over Beef and Wireshark, two really important hacking tools in Kali Linux. Alright guys, now that Adam is done with his presentation on Beef, we're going to go ahead and move on into Wireshark. So before anything, if you're wondering if I recorded this after, I am, because we didn't have time to finish it all in the actual meeting, so I decided to go back and basically restart or start from the beginning to make it faster for you guys and easier to understand. So first of all, go ahead and click on the link in the description. It's going to take you here and download this file. It's a zip file that has the data that we're going to be analyzing with Wireshark today. So just hit download and then hit save file. And by the way, if you have trouble accessing the internet with Firefox through Kali, shoot me a PM and I'll help you out. There's ways around that to fix the fact that sometimes Kali doesn't recognize the network interface card, as I said before in the start of the video. But anyways, so while that goes ahead and downloads, what is Wireshark? So I mean, at the most basic level, it's just a tool to analyze network traffic. So I mean, yeah, that's pretty much it. I mean, let's say you have a home office or a regular office, whatever, and you have a bunch of computers here, all like, I don't know, accessing the internet to upload some work files, let's say. So these computers, at a physical level, they're all connected through wires to a router or to a modem, and eventually to a modem to communicate with the internet. And so if I'm an intruder, for example, and I get into this network, and I connect my computer, for example, to it, I might not necessarily have access. Like, I might not be able to log into this computer remotely and screw around with his keyboard or his mouse. But I can see the data that he's transmitting from here to the internet because I'm connected in the same local area network. It's a LAN. That's what a LAN refers to. And so, I mean, technically speaking, there's ways around this. Like, not everybody can see each other's data in a huge company, for example. There's ways to hide that from the other computers on the network. But for this example, we'll imagine that it's an insecure network, and that I can connect and see the network packets. That's what they are. It's network packets that are being sent through to get data from the internet. So that's what it comes down to. And with Wireshark, we're able to see those packets of data that they can have the name of the website they're logging into, or they can have the name of certain files that are being downloaded. It can have a lot of things. And to show you how many things it truly has, I'm going to go ahead and open up Wireshark here in the first place. And to do that, you go into sniffing. You hit this button on the top left first. You go into sniffing and spoofing, and then you hit Wireshark. So what I'm going to do here is I'm going to take a capture of me just using the internet. So what I'm going to do is I'm going to start up the capture on this device here. This is my network internet, or my network interface card, the thing I use to access the internet. So you start the capture here. You can already see data there, but what I want to show you is, like, if I go to, GitHub.com, or if I go to bcps.org, I think is, yeah, that's Baltimore County. Oh, never mind. Well, either way, it doesn't truly matter. So I'm going to go ahead and stop this packet capture here, and we're going to go ahead and analyze to see what website we actually access. So look at this, first of all. Like you're under no circumstance, like, as a network analyst or as a hacker, would you ever be expected to be able to, like, look at all this data and see what each packet means. So the key here is to isolate the information that is actually important to us. And what I want to do is I want to see which website I was accessing. And to do this, what we actually want is the DNS protocol packets. DNS is a protocol for networking. I'm not going to explain this entirely in this video, but basically, when you type in google.com, like I just did, or github.com, your computer, and furthermore, like, your router, it doesn't know, it doesn't physically tell the internet, hey, I want to go to github.com. It tells it the IP address of github.com. So I don't actually know GitHub's IP address, but I mean, they have a ton, probably, is the bottom line. And DNS servers, what they do is they they take your text saying github.com, and they contact the DNS server that basically then gives you the numerical IP value of github.com. So let's say it's 1.1.1.1. It's not, but let's say it is. The DNS server takes that, it converts converts github.com into that IP address. So let's see here. So going back into Wireshark, right here, we're going to look at a DNS packet that tells us what website we tried to access just now. So all the DNS packets are here, and I actually have a bunch of people on my network. I have my my sister and my dad and my mom, for example. So they also, these packets also capture their data potentially. So to see the actual website that we queried, queried just means like ask. Just pretty much ask. To query is to ask for something. So right there, that was not github.com, and that was not google.com. So we know that it's not that. And taking a quick glance at this, you don't always find it. Sometimes you actually have to let's see. Okay, yeah. So there we have github.com, for example. That is a packet that contains the information that we try to access github.com. So that's just one example of the stuff that you can find in Wireshark, but that's not what I really want to get at, because that's kind of boring, because a lot of this information doesn't really matter. It's just sort of boring internet access and internet traffic. So, but this is this element of isolating information from a network packet capture is what we're going to be dealing with today. So after this is done downloading, you're going to want to go into your downloads directory for Firefox, which is, in this case, downloads. So if you type in ls, you're going to see the file name here, which is FishyBusiness.zip. And what we're going to do is, for simplicity, we're going to move it to the desktop right here. And to do this, we're going to do mv, which stands for move, and then FishyBusiness. If you notice there, I typed in fi, and then I typed in tab to autocomplete the name. And then we're going to do /home/Kali/desktop. And well, this is what you guys are going to type in, because in modern versions of Kali, you have sorry about that. You have the user called Kali, which is not a root user by default. If you notice here, my terminal is being used by the root user. I configured this myself after the installation, and if you want to know how to do this, you can also PM me to find out. But for you guys, it's just going to be this. And yeah, this is a directory for you guys in modern Kali versions. But for me, it's going to be /root/desktop. And if it says you don't have, if at any point in this video it says that you don't have enough permissions to do something, it's a simple fix. All you have to do is type in sudo at the start of the command. I don't have to do this because I'm in the root user, which is like the administrator. That's what you call it in Windows. So I don't have to specify that I'm an administrator, since I have the root account. But you guys, if you haven't configured this, it's going to be a non-root account. So it's a simple fix. Just type in sudo if it doesn't work. But for the most part, it should be fine. So, all right. Yeah, so now we have the file there, or the zip file that has all the network information inside of it. So we're going to go ahead and unzip this by typing in unzip. Oh wait, actually I have to change my directory. If you can see right here, I'm still in the downloads directory here. And what I'm going to do right now, I don't know if you guys see this, but my screen is kind of yellowish because of a nightlight setting that I have on. I don't think you guys can see that, but in case you can, I'm going to go ahead and disable that really quick. All right, there we go. So yeah, so cd /root/desktop. For you guys, obviously, it's going to be /home/Kali/desktop. So yeah, now that we're here, ls, and you can see the file name there. So okay, so now unzip FishyBusiness.zip and just hit enter. And just like that, we have all the files that were inside this. We have them all here now. Go ahead and move these to the side to make it easier to see. So yeah, so we have all these files here. And well, first of all, we want to open the README, because this is where the actual challenge part comes into play. So why do we have this file? So let's read it. So the security team was alerted to suspicious network activity from a production web server. So can you determine if any data was stolen and what it was? Just give me 1 second. Alright, so data was stolen. So that's one of the key parts in this README right here. And if we look at the actual files that they present to us, you guys might not be familiar with this type of layout, but first of all, we have a pcapng file, which is a packet capture file that can be used to look at a bunch of packets all in one single go. And what we have here is a folder called bro, which with a bunch of logs. So this is going to look really foreign. I'm not going to lie. If you're not familiar with network intrusion detection systems, so what this is it detected suspicious activity, like it said in the README file, and it wants you to analyze it. And so these are the logs from the time periods that it detected suspicious activity. So we're going to go ahead and open a few of them. We're not going to go through all of them because, or actually, we're going to take a quick glance at all of them now that I think about it, because I think it's important to understand to be able to dissect this this freakish looking file, because while it may seem complicated at a basic level, it really isn't. I mean, it is, but it isn't, and you guys will see what I mean here in a second, because to understand what these columns mean, we have to look at these fields right here. This is the fields line that tells us what each column represents. So, for example, the first field, or the first field here, is TS. TS, you're not supposed to understand this directly necessarily, but because I know the network intrusion detection system that was used, I know what TS means, and TS stands for timestamp. And to be honest, this is for like all network logs. TS is always going to stand for timestamp, and there's a bunch of acronyms that you can find out by looking up. If I go to Google and I look up, for example, bro, so it's in a folder called bro, right? And so what does that tell us? Well, there's a bunch of logs in this, which means that the system that collected all these logs, its name might be bro. So, and indeed, if we go here to the internet and we look up bro logs, we see a few links here, and in a normal situation, you would go through these and you would try to find out the actual software that it's from. In this case, it's from a software, or it's from a network system called Zeek. So just so you guys know that I'm not lying here. Yeah. So Zeek, which was formerly Bro, is a open source network security monitoring tool. So this is the key thing to understand when we look at these files. So yeah, so as you can see, formerly Bro, that was the tool that it was called before that, and in this case, yeah, this is an old challenge, so it was called Bro. So yeah, bottom line is you can open this and it tells you, or it gives you, all the logs of the suspicious activity that happened in the network. So we're gonna go ahead and open up connection logs again, and so here we see timestamp, unique identifier, the origin ID, the origin ID hash is what this is, and the origin ID IP address. And then it gives you a few more things, but honestly, this doesn't really give us anything useful. I can sit here and scroll through this all day long, and the only real thing that I'm going to get out of this is the fact that there's a few IPs that are using this network at the moment, and it's 10.10.100.43, and then I saw this other one right here, which is 10.10.20.13. I mean, that's all I know. That is literally all I know. I know what port they're using, which actually might be something useful. If you guys don't know what ports are, then I highly recommend checking out the Club Udemy account. It has a great course on networking. You don't need it for this, but if you want to understand what TCP means, what UDP is, and all the rest of the stuff, then it's a great course. But anyways, moving on from that tangent, yeah, so okay, we know the IPs that are using the network. It's 2 IPs that are doing suspicious activity, but other than that, it's kind of whatever. I mean, not so much information gained so far. I'm gonna speed through this to make this a little shorter, but yeah. Anyways, DNS log. Oh, now we have something actually potentially useful, and we have a bunch of websites right here. So I'm gonna scroll through these, and you guys tell me if you see anything suspicious at all, any suspicious website that's being accessed here. And yeah, all I'm doing is I'm just gonna scroll through this really quick. Okay, did you guys catch anything specific or anything suspicious? I went through it kind of fast, so you probably didn't. But scrolling back up, a lot of these websites are just stuff like, this is an image site, this is just Reddit. I saw like Amazon over there. And yeah, just like some random websites that you can, in a normal situation, if you don't recognize them, you would look them up and see if they present any suspicious, or they indicate any suspicious activity. So in this case, you can look these up all you want. They're not going to give you much information. What is going to give you information, though, is this right here. So it's a pastebin. It's an IP address, which is 10.10.20.13, using, or well, it's accessing the website pastebin.com. And so just like how you guys saw how I access, or how I looked at my DNS packet information with Wireshark, we're pretty much doing the same thing here, except through a log format. And now with that, we're able to see that it's trying to access pastebin.com. And so if you're kind of if you use the internet a lot, if you're on the internet a lot, you might know what pastebin.com is. And the reason why I say that's suspicious is because pastebin is known for, when there's a leak, when there's a data leak for like, I don't know, some email server or like some insurance site, pastebin.com is usually where you're going to find a lot of the account information for when these leaks happen. So I mean, I'm going to go ahead and look at to see if I can find anything here. So look, this guy posted a bunch of leaks on pastebin. More, email addresses on pastebin here. This is actually pretty LinkedIn leak database. See what I mean? Like, this is what, it's not the only thing that pastebin is used for, but the fact that a corporate network, which that's what it is, the file here is it's a team. Hold on, let me see what it says. Yeah, the security team. This security team, it can be from a company, it can be from like a government. The bottom line is, if they have a security team that has a network monitoring tool like this, and they're asking you to do something, it's because their traffic is going to be heavily under heavy scrutiny, And when you have a website like Pastebin there, coming from a corporate environment, you have to ask yourself, okay, that's not normal. So the bottom line is, we have that website here, and we have the IP address associated with it, which is 10.10.20.13. And with that, we're ready to move on to the Wireshark capture. And I actually have it open here, which I'm going to close real quick. So we could go through the rest of these logs, but right now I'm going to go ahead and call it that is the IP that we wanted to analyze. So, all right, so let's go back to the files here on the desktop. So these two files here are related. You know how I told you guys before that encryption or that traffic over a network in the modern day is encrypted? These files have to do with the encryption that was used to transfer those packets of information. And we're going to get to that in a second. But before that, go ahead and open up the let's see, challenge. It's called ChalCap. It stands for challenge capture, I'm guessing. It's a Wireshark, or it's a PCAP file that can be opened with Wireshark. So we're going to go ahead and do that here. And if you double click it and nothing opens up, just go ahead and open up Wireshark through the top left corner there, and just go ahead and drag and drop this. It does that sometimes for some reason. I don't exactly know why, but like I told you guys before, sure, like, yeah, we have all the packets that were being sent through in this time frame that they gave us, but it's not really too much use if we're just sort of like going through and like guessing which one might be suspicious. So but since we have the IP, we're able to cut this list down significantly. So I want to show you guys what we're actually going to do here. We're going to do IP.adder, which is just telling it to look for a certain IP, and we're going to do 10.10.20.13. I'm pretty sure that was the IP that we saw was trying to access pastebin. We're going to go ahead and type that argument there. So, and you know, it was a big list before, and it's, to be honest, it still is a pretty damn big list now. Like there is a lot of files here that that we have to go through, but we're not going to. We're not going to go through all of them. We're going to go through a few of them and see what we can find. So here we have this file, okay? So it's a TCP packet. TCP is what, like, generally everybody, like, it's a protocol that is, like, fundamental to almost all network communications. So what is this packet? What does this packet actually have in it? So we're going to go ahead and take a look at this here. Yeah, well, it's a TCP packet. Nothing too much that we can gather from here. So what we're going to do is we're going to go ahead and follow this packet, follow the stream of this packet to see if there's any information inside of it that we can access and see what's going on. So, okay, a bunch of gibberish for sure, but also a bunch of useful data. So, okay, so it's trying to ping a site first of all, and it was successful, and it moves on, and it gives you a few more, a little bit more data about what the information, or what the guy is physically trying to get. And look at this, look, cat/etc/password. He's trying to, so already you can see something suspicious from this guy. He's trying to access a password file in some sort of directory, and okay, so that just makes it even more suspicious than it already was before. And okay, so moving on, he's using the curl tool, which I'm not going to explain it in depth right now, but basically what he's trying to do, you guys see how he is trying to access this directory and he's trying to get this information. What he's essentially doing is he's requesting this information in one way or another. And what we have here, and I don't know if you guys caught this before, but look at this. So what is this? These are literally American Express credit card numbers. That's what they are. And there's only 3. Like, we don't have much to work with here. There's only 3 here, and besides that, we don't physically have anything. We don't physically have all the credit cards. Like, this is not all the information that was stolen. This guy sent way more packets. This can't be the only thing that he got. It might have been, but for our purposes, we're gonna assume that it isn't. Like, if you're a security analyst, you're not gonna see this and stop at there. Like, stop at that point. But already, you guys see the power of Wireshark. We're able to isolate packets, and here we got lucky because these specific credit cards, the guy was dumb because he requested these credit card numbers, but he did not encrypt them, right? So you have these credit cards here. He got 3 of them, and then he realized, oh crap, I actually got them now, but I didn't encrypt it. I'm gonna go encrypt them and try to get some more. So, okay, so we have those, and so already we understand a huge part of what went wrong in this case. So going back to the original packet capture here, I want to show you guys there is a lot of HTTP traffic going on and a lot of TLS traffic, or TLS is in this case is being used on top of HTTP. But this is a key thing to know because to encrypt, so already we know the guy is accessing some sort of database through the internet. And if you guys don't know much about ports, HTTP is the port that is used for web data transfer, basically. So 2 things that we can gather from this is by scrolling through and seeing that that the TLS packets are being displayed here. We know that at some point the guy decided, oh wait, I need to make this data encrypted. All right. So, and I want to show you guys something important here. If you try to access anything inside, like look, this has application data, for example. If I want to access this application data, guess what? I can't. You scroll down here, transport layer security, and I just want to show you guys encrypted application data, blah, 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 blah. So if we right click and we try to do the same thing that we did for the TCP stream that we saw before, I'm going to show you guys that it's a bunch of gibberish. Like, you cannot physically understand this because it's encrypted through TLS. And I'm going to show you guys one more example. Even if I try to follow the TLS stream, you're really not going to get much. Like in this case, you get nothing, to be honest. So what do we do now? Well, okay, we have these two files here. So the guy was clearly on their network, right? And so just how I showed you guys before, how computers on the same, well, I don't have the picture up anymore, but if you're on the same network, you can gain certain information about someone's connection activity that can allow you potentially to gain the keys needed to decrypt this data. And so we have two pretty much keys here. One is a .pem file, which has to do with RSA encryption. RSA encryption is a form of asymmetric encryption, which I'm not going to go too in depth if you don't know about it yet. But basically, it's a method of exchanging data that makes it so that you can encrypt a password with a public key, and you can only decrypt that password in this case with your private key. So it's a two-key system, and that is what this key file refers to. So to use this in Wireshark, what you would actually do is you would go into Edit, Preferences, and then you would go into RSA keys. The key file in this case would be the .pem file here, but to shorten this process, I'm going to tell you guys that you don't actually get much out of that. If you type that in, what you're basically going to be getting is nothing new. And what that tells us is the guy did not use that specific form of encryption, which was RSA. Instead, what he used, or instead to decrypt his traffic, the network administrators have provided us with a secrets.log file, which this is just the key. Basically, this is literally the key to the traffic that he was on, or that he was sending. And to actually get this file, you guys might be looking at this like, okay, but how did they get that? Like in a real life scenario, like how would you be able to even like get that file in the first place? And I'm gonna show you guys here the actual command to get this, and it's pretty simple because this guy was on the company's network in this case. For example, the company having access to his traffic is able to gather certain information about his session. That's what it's called, his session to the internet in this case. So the command to actually get this file in Linux, at least in Windows, it's something a little different. What I'm going to show, or what I'm going to type in here, I'm not going to go through the whole process. Oh wait, I think you guys might be seeing a black screen. Oops. All right. So yeah, in Linux, what you would do is you would type in this command right here, and what this does is Firefox, when it's accessing Google.com, you see this little padlock here. It is encrypted using HTTPS, which uses TLS encryption. So with this, you're able to type in this command to generate a key for the traffic that you're sending across the internet. So this is something that as a network administrator you can specify, and you can tell the guys, or you can tell everybody that's connected to the network, hey, you have to give me this file. This guy was on the company's network, so the company has the ability to get this specific file. And so yeah, now the question is, how do we actually implement this into Wireshark? And so it's similar to before. You want to go into Edit, and then into Preferences, and then you want to go into Protocols, and then scroll down to TLS. Once again, if you guys are confused about what TLS actually is referring to and how it works, highly recommend our Udemy courses that we have through our paid club account. So, okay, so I actually kind of cheated here. Not really, but no, because never mind. The point is, this is gonna be blank for you guys. So, and to actually get it in there, you're gonna want to hit Browse. Go into, in this case, it's desktop, and then secrets.log. That's the file that you're gonna tell Wireshark to use as a key to decrypt the TLS traffic, the HTTPS traffic. So we're gonna do something interesting here. We're gonna hit OK, and we are going to it's gonna refresh there. Just give it a second. So we're going to do the same thing as before. IP adder dot equals or equals. Oh god. .10, .20, .13, and I want you guys to notice something here. Now, did we have this HTTP traffic there before? The answer is no, we did not. And why was that? Because the HTTP traffic that we had there before was encrypted. And so by isolating this IP address, we cannot find the traffic that this guy decided to encrypt later on. But now that we have the key that was gathered by the network administrators, we're able to isolate his IP address and get the specific HTTP information about the traffic that was being sent through. So, like I showed you before, he did mess up. He did get some credit card information without encrypting it. So he kind of blew his cover there. And now that we know that, we're able to investigate even further and see the fact that he encrypted it and access that encrypted data. And basically, the fact is, it's all going to be in one of these HTTP, encrypted HTTP files. So, and we got lucky because it's only, like a couple, 7, 8 here. And so with this, believe it or not, there's ways to go about making sure that it's even more specific. But for our purposes, I'm going to go through and just guess and check, So to actually do this, we're going to go ahead and follow the HTTP stream. We're not going to do the TCP stream this time because if you guys remember, like we did before, it's a bunch of gibberish. Or in this, it's a bunch of gibberish because it's encrypted. But if you go back, hold on, let me scroll up here. If it lets me. Oh wait, hold on one sec. Adder. Alright, let's just let that load again real quick. Oh wait. Can't type apparently. So now, I don't know if you guys realize the power of what we just did. We took this this data that was encrypted using a TLS, which is super it's a super hard thing to decrypt by brute forcing it. So just because we decrypted it here does not mean that you're going to be able to decrypt it as easily with just any random dude's network traffic. TLS makes it so that information is super hard to decode unless you have the key file here that we have, because this guy was on our network. He was not on some other network that we don't have administrator privileges on, and that we can't access his key file. But in this case, we are the owners of the company is the owner of the network, and they are able to access that information. So, anyways, moving on here, I'm gonna go ahead and guess and check on a few of these to see if we find anything important or anything that stands out to us. And to be honest, I think I'm gonna fast forward this until we actually get somewhere interesting. Like right now, this is it's nothing really important here, except for the fact that he submitted a post request. If you guys know what a post request is, I'm gonna leave that there for you guys to think about. If you don't worry about it. We're just gonna keep on going through the few files that we have left. So let's see. Okay, so what do we have here? We have, look at this. Just credit card after credit card after credit card after credit card. And I mean, this is it. Like, this is it right here. The guy realized, oh crap, you know, I took these credit card numbers in a decrypted manner, or in a plain text manner that everybody can see. I'm going to try to hide it. Obviously, the guy is kind of dumb. He wasn't able to hide it because we accessed his key file from his HTTP traffic, and guess what? We have not only all his credit card information here, or not his credit card information, but the stolen data. We're able to figure out whose data got stolen and what to do, and you know, to cancel their credit cards. And we actually did the challenge. This right here is the key. Like, this is the flag. On HackTheBox, which is where I got this challenge from, what you would do is you see this key here. It's in this format. They tell you what format it's in, and you submit this into the website, and they give you points for capturing the flag. And that's pretty much what we just did. We just captured the flag. And not only do we now understand what Wireshark is and how to manipulate it, but now we actually know we're actually introduced to something that in the future I want to, as a club, be able to do in competitions. Because with this, this is a whole forensics challenge that we just finished, and in a real competition scenario, we would have gotten points for this. So I just want to show you guys how cool that is. First of all, because like, not only are you learning hacking, but you're learning how to secure your own network traffic in this case, and how, you know, potentially how it could go wrong. So there you go. That's pretty much it. That's all there is to the challenge at this point. If you want, you could go through the rest of the HTTP packets to see if there's anything else. I'm going to tell you right now there isn't, because I just know. And because this is like the file that has this is the packet that has the flag. So in a competition scenario, you would not go past this. You would just submit this and you'd be done. But in any case, that is what Wireshark is. And you know, we're about 38 minutes into this. I hope you guys didn't find this too exhausting. And listen, if you have questions about any of this, what TLS is, TCP, HTTP, just go ahead and message me. I have so many resources to learn about this type of stuff and to get better at understanding it. But other than that, I wanted to thank you guys if you made it all the way to the end, and I want to definitely recommend you that if you did make it to the end, to participate in the next competitions that we're going to be in. More details on that soon, but besides that, that's pretty much it. I want to thank you guys for watching and for sticking around, and you know, thank you guys for coming.